So wouldn't it be nice if we could auto-generate our tests? Well, that'd be good. Let's find out. Put your hands together, please, for Frank Rehberger.
Okay, welcome to everybody. So I've got to rush through. I've got 15 minutes before lunch. So I will introduce myself. I'm Frank Rehberger. I'm living in Berlin. So I'm a software security consultant, Rust enthusiast, and regarding Rust, so I implement, for example, the N-body or benchmark games, N-body Rust implementation, which is now ranked 1 in the N-body benchmark games. So and bypassing Fortran and all the others. I'm talking about testing. So I'm stepping back from hardware, so it's more building and testing. The sources I present here are available on GitHub, if you like. I'm talking about test generators at first. So the background was I implemented an IDL parser, and I had a lot of test inputs I had to test for to verify the IDL parser is working fine. And I was looking for a test generator to produce or create a number, or a huge number of tests based on file inputs. And so there was nothing available, so I had to look around, and I implemented one solution based on proc macros. And so the test generator, more or less, is the intention is to create many different test functions. I can show you later how this works, so it's more a practical introduction. I will show you how another implementation works. This is test-case-derive crate, which is implemented by Martin. And so we'll have a look at the test generator I implemented, and I will talk a little bit about dependencies regarding if you deal with external files that are not Rust files. So how are they handled? How can you handle them? So the layout of my package I'm using for this demonstration is very simple. We have got we have got a main function. This is useless for this demonstration, but we have got two integration tests: demo test-case-derive and demo test generator. We have got data directory structure with a specific hierarchy, and we've got some IDL-files in here. We have got a build script in here, and I will go through and explain what they are good for. The manifest looks very simple, so we have got development dependencies based on those two crates, and we have a build dependency which is regarded or related to the build script we are using. The test-case-derive functionality allows you to implement a single test function and declare multiple tests that should be run using this test function. So we have got two parameters, x and y, and we can define line by line test cases and name them with a specific name. And when we build the project and run the project, we will end up with multiple tests that have been generated. And so implementing or realizing the multiplication test for a specific named test case and yielding the result. So this allows us to go back. This allows us to implement, or this avoids duplication of code for a huge number of test cases. So we just have to maintain one test implementation, and we can invoke this test with a huge number of different inputs and verify that this is working. The test-case-derive is intended for values, parameterized test over values. But in my situation, I had the problem that I had files as input. And I had to deal with the case that I've got one test case which should read one or two files and doing some processing and checking if my functionality, my IDL parse is working fine. So in my case, using the test generator, it's a similar approach. So I'm implementing one body, one test function, and then I define or instantiate a proc macro from my create test generator, which is called test expand paths. And this one will expand this pattern and enumerating all the files matching this pattern and creating or generating tests for every file being in this subdirectory data. So when we run this now or compile, we get an output. So we had two, as you might, as you saw before, there have been two IDL files in my data hierarchy, and now these have been expanded, and so I get two tests being generated: test file, data test1 foo IDL, and test file, file test data test2 bar IDL. So that's exactly, if I go back to the layout, so it's exactly what's inside my data folder. So this is nice, but so it helps us to reduce maintenance every time we add a new test vector into the file system, into the subfolder, and we recompile. We get a new test case which will be executed and is verifying the test case. Or this. So the problem is iterative builds. So we don't want to rebuild every time the whole project. So the problem is we want to declare a dependency and say that this crate should be rebuilt only if one file in there has changed. And so here we come now, we're getting to the question, how do we declare dependencies in Rust projects and regarding a crate? So Cargo or Rust compiler, they're able to handle different dependencies. The RS files, the Rust files, the source files, external crates, include macros, which is interesting. If you use the include macro somewhere in your code, the Cargo and Rust compiler will monitor this, scan this, and every time this file, which had been included, this file is modified, Cargo and Rust will rebuild the project on the next iteration. So, and another option to define a dependency is using build scripts. So build scripts are used, for example, to compile a native C code or whatever. So we must be able to define which headers your Rust code, your Rust wrapper or whatever depends on. Like Rust source headers and other files. So in my case, I had the intention to create a dependency to the IDL-files. My IDL compiler should process. One interesting point is also that, so how does it work? So the build script in our crate package is executed and it's able to communicate back over standard out to Cargo. So everything, or not everything, but specific commands can be printed to standard out by the build script, and Cargo will read them and interpret those commands. For example, you can tell on return a string on standard out and tell Cargo how to link or where to search for specific packages. But also the dependencies. You can tell Cargo rerun if changed and specify specific path. And Cargo will collect this information, store it, and the next time Cargo gets a build command, it will analyze this database and check the timestamps of all mentioned paths here, if anything has changed. So it might be a file or it might be a directory. A directory, a timestamp of a directory changes if a new file has or new directory has been inserted into this directory. So this way you can monitor directories, removing subdirectories, adding subdirectories. You can, if a file has been added, if a file has been modified, so you can declare or you can monitor this way. You can monitor all these situations. So what I did is very simple. I just combined this feature with a pattern, with a glob pattern, which is reading or taking a file pattern, expanding this file pattern, and calling for all the entries matching this file pattern this rerun if changed, and telling Cargo to monitor all these, the complete enumeration. So if we create a build script now, we tell, for example, we depend on the build depth crate, which is more or less just a two-liner. So it just so it's expecting the pattern, the file pattern. In this case, subdirectory data with another subdirectory in there and containing a file.idl. This pattern will be expanded using the glob Rust library, and a for loop will enumerate or iterate this list and print for every entry of this list will print to standard out this rerun if changed command for Cargo. This one is intended for if a new subdirectory is added. So this one will observe if any subdirectory is added to your test data vector or removed, and this one is just so it's similar, but it's a similar directory. So just a sequence diagram. So we start Cargo build. Cargo build will check if any files that are should be monitored have been changed, and if not, it will build and execute the build script. The build script, as we saw, is executing a rerun of changed paths with a filter pattern. This will use glob to expand this pattern and then print on standard out the rerun of changed back to Cargo. Right? Okay. So so achievement. So what have we achieved? So this way, with proc macros, we are able to implement test generators over values, file entities, and we can monitor those files if files have been added, modified, or deleted. So these are the references or the resources, if you like. You can download it from GitHub, and I thank you.